All right, started. Let's go to the Yale site. All right, let's get to our course and let's get a code from here. So last time we managed to put an asteroid on the screen, right? The asteroid has inertia and has thrust. So today what we want to do is add missiles and maybe maybe the asteroids, right? And next time maybe we talk about collisions, which is tomorrow. Cool. All right, so let us start. So before we do anything, let me clean up the code a little bit. All right, so generally we are going to take this into a function that draws the ship. All right, so I'm just going to delete this. All right, so I'm gonna say Control X or Command X here. I'm gonna go above and I'm gonna say draw ship def draw ship, and we're going to figure out what arguments we need there, and we're going to perform this operation as well as the drawing itself. Ship position actually has to come first. And then we will return ship position. All right. And we will take in here the ship position. All right. What else do we need? So we need this key up down flag, which is set up here, right? So ship position, key up down. Ship image is global, ship angle is global. Oh, actually this one is global as well, so no need for it. So only the ship position needs to be in. All right, and then right here we're going to say ship position. Do we need the ship position further? Probably not. So we're going to say draw ship position. All right, so we're changing the ship position just in case. Yes, we need that because the ship position is actually global right here. So we're going to say ship position is assigned draw ship of ship position, right? So this cleans up the code a little bit. and makes this draw function more compact and leaves some space for some other drawings that we may want to do. Let's run again and make sure that we haven't gotten anything wrong, and we actually have. So canvas has to go here as well. So we're going to add the canvas first, and we're going to pass in the canvas here. So if we run now, we have to always add the focus into the window, and this window is a little bit too large. I could also close this, so now it does fit. Okay, works fine. Close. So what's next? Next we want to have missiles. All right, so the missile image is here. Yeah, we have seen what the missile is. All right, so you see this little blob here, and actually I would like you to see how big the image is. All right, so in order to do that, we're going to look at the elements of the page, and oh well, the image, let's go on this element, and then here I would like to add a border width. Can I add a border width? Margin auto. Here I would say border 1 pixel. And if I say that, the border is going to be black border. Color, let's make it white. No? So anyway, I would like to show you that the image is very small. It's pretty much exactly the size of the missile, right? And because of that, we can actually consider it as just one point. In fact, if we look at my original source, which is where we got the images from. All right, my original source was here. All right, for the missile, the size of the image is 10 by 10 pixels. This is really small. The center of the image, as you might expect, is at 5 and 5, right? So it's pretty much just 1 point. So we are going to have a missile that originates at the tip of the ship. Yes. How do we know the tip of the ship? We know the orientation because you know the angle, and remember that the radius, what we consider to be the radius of the ship, was 35. So going back to the code, this is very annoying, this panel that just slides down and then stays there for a few seconds. All right, so in order to remember the ship radius, let's put it here, right? So this is a constant, so I'm going to say ship radius. which is 35 pixels, right? We consider the ship as being kind of a circle or a disk, right? This is going to be useful for collisions mostly, but it's also useful right now to know where the tip is, right? So the ship position, we know it's here. We're going to know the ship angle, and we're going to go along that angle for a distance equal to ship radius, and that's where we consider the tip to be. It might not be exactly there, but because things happen so fast, it will appear as if the missile, it originates from the tip of the ship. Now, we're going to have a bunch of missiles, right? So also in this area where we have all the variables, I'm going to have missiles, and the missiles are going to be a collection, which is initially empty, right? So each missile inside, what we're going to have is a position for a missile, and we're going to have many elements. So I'm going to have maybe 100, 100, and maybe 200, 200. I'm just giving an example, right? Which means that we have one missile at position 100, 100, another position at 200, 200. And more than that, each missile should come with an angle, right? Let's say we use angles in radians, right? So it's going to be some angle 0.5 radians, some other angle 0.7 radius. And then it has a constant speed. All missiles have the same speed, and we're going to pick a speed for that. We're going to say missile speed is, and I'm going to pick something like, it has to be relatively fast. So let's say 5 pixels per frame. And then each frame, we're going to advance the position of each missile by this many pixels in the direction given by this angle, right? So this is how the missiles are going to move, all right? Every time we fire a new missile, we add that missile to this list. And then every time a missile leaves the screen, we have to make sure that it also leaves this collection, so that otherwise we will keep growing the number of missiles in the collection on and on and on. And at some point, there's going to be so many of them, the whole game is going to slow down, right? But we are starting with an empty collection. All right. So the key that will launch a missile is the space, and you see that currently we have here a pass, right? And then we don't have press and release. We only have the press. When we press, we release a missile. When we release, we do nothing, right? So there's nothing to do in this part of the screen. And so whenever we do this, we can go directly and add a missile into this collections, right? So we're going to say missiles dot append. Was it append? I can't remember exactly which one it was. So let me open. So if I have L is 1, 2, and then I say L dot append 3, and then I want print L. What does this do? 1, 2, 3. Wonderful. So append is what I need. Sorry, I should be here. So missiles.append, right? And I'm going to append an element, which is a triple, right? So the triple consists of the current ship position, right? So I'm going to have ship position 0, which is the x coordinate, plus ship radius and this is times cos of ship angle, right? Yes. So plus ship. So this will be the position of the tip. This is where the missile originates. And then I'm going to have ship position. So this is the y coordinate. 1 plus ship radius times sine ship angle. All right. So this is a triple. Let's try to print it nicely. First component, second component, and the third component is the actual ship angle. So the missile is going to move into the direction of the ship. All right, so we're closing the triple and we're closing the bracket that denotes the method call, right? So we have created the missile. That's a very simple thing. Yeah. Now, inside here, we have to make sure that we advance all the missiles, right? So we're going to have a loop for missiles, missile in missiles. And what do we do, right? So M is one missile, right? So M is a triple. So we're going to say mx, my, m angle is m is equal to m, right? So this will decompose the triple into its components, right? And then we have to draw the image. We have to draw the image. And in drawing the image, so this is canvas.draw image. And so one thing is missile image. Do we have the missile image here? We have the missile image, yes. And then I'm just following the model given here, right? So I have to select from the source image, right? I have to select the center, and I have to select the surrounding box, right? So the center is going to be, we know, at 5, 5, and the surrounding box is going to be 10, 10. And these are constant, and we don't need to fiddle with them as well, at all, right? And we're going to put this at mx, my. All right. We don't want any scaling, so we're going to keep this 10, 10. And I think we don't need these coordinates anymore, right? Because these coordinates are optional. If we want any resizing, we can do resizing. And if we want to rotate, we rotate. But we don't need to rotate the missile. The missile is so small that, and it's sort of like a disk, so we don't need to worry about it. Now, we need to advance the missile. So I'm going to have a new position x, new missile x position, which is going to be right, mx plus the missile speed. Do we call it speed or velocity? I think velocity is the more physically correct term. So missile velocity times cos of our missile angle. All right. And the new missile y is my plus missile velocity times sine of missile angle. Now, what happens is that these new coordinates may have left the screen, right? So we will compute a new missiles, which is initially empty, and then we're going to add back into this collection only those missiles that are still on the screen. Yes? So if 0 less than equal nmx less than equal width, and 0 less than equal nmy less than equal height, right? If this is correct, it means that the missile is still on the screen, and we're going to have new missiles dot append. And what's the new missile? nmx, nmy, and the angle stays the same, right? Because the missiles will keep going in a linear direction as long as it keeps moving. MA. All right, once we're finished with this loop, we have to replace the old missiles by the new missiles, right? So we're going to say missiles equals new missiles. We have to remember to add missiles to the global set. Yes. And now we should have missiles. So let's see if this works. All right. Something was wrong. So name error costs is not, because I think we have to say math.costs and math.sign. And let's make it nice. And we have to, whoops. Did you lose the connection? Yeah, are you connected now?
Yeah.
Okay. So math.cos, math.sign, and then let's try running again. I have to get the, all right, so I still need to actually say the 1010 here. I thought that was an optional argument if I didn't want the resizing. Okay, so they're not so we are putting them on the screen, they're not moving. Let's see what's wrong there. So the missile velocity is 5, and I think we need missile velocity here as well. That's not it. right, so let's do here. Am I spelling correctly? Of course not. So forget about this. It's a spelling error. All right. Okay, so we have missiles now, as many as we like. Yeah, everybody can see this? Cool. Are there any questions so far? Do we still have... Yeah, we still have participants. Okay. No questions. Cool. So let's go and do something similar about the asteroids. Right, so we have the asteroids. Let's again experience the asteroid. And where do we have it? I think here we'll use this one. All right, so this is the asteroid. We want, for effect, the asteroid to rotate at a random speed. So the asteroid will go into a random direction at a random speed and spin at a random rotational speed. Which rotation at the random speed will not change its trajectory. The trajectory will still be a line, will be linear. From my old code, we know that the asteroid has a size of 90 by 90 and a radius of 40. Yeah, and again, this will be useful for collisions. Nothing else in this case, just collisions. But we know that we need these coordinates for these values for in order to draw it on the screen. So we're going to take a similar approach, right? We're going to have a asteroids collection, which is going to be empty initially. All right. And we're going to have a speed limit for the asteroid. So limit, which is going to be maybe something like 2. And we're going to have an asteroid angle rotational rot speed limit, which is going to be maybe something like pi divided by 30, something like that. I have no idea what that means, whether that's going to be nice or not. Let's give it a try. So I have velocity limit, a rotational speed limit. They're going to appear anywhere on the screen. Later we'll see that we want them to appear somewhere where it's not too close to the ship to give the player a fair chance, but we're going to fix that later. So they're going to start at a random angle, and we're going to have these limits on the velocity and rotational speed. Okay. The other thing is we want them to spawn at a random time, right? So in order to have this, or maybe not so random, right? We're going to say every second there's a new one. right? So we're going to have a timer, and every 1 second, this thing is invoked. Yeah, and actually, let's make it random. Let's not make it. Let's not make it every single. Let's not make it every single second. So we're going to have a procedure called def rock spawner. I think that's what we call it. We're going to spawn a rock. All right, and what do we do here, right? Every once in a while, we have to fill in this thing. Yeah, that's the only thing, right? Creation means populating this connection, and then inside the draw, whatever is inside that connection gets rendered. So we don't want to do it every single second, right? So we're going to have a random number generator, right? So we're going to use random.random. Which random.random? Let's remember what that does. So I'm going to import random, and I'm going to say x equals and print x, right? So every time I run this, I get a different number between 0 and 1, right? So I'm going to try to spawn a number not very frequently, right? So if I'm above, let's say maybe on average every 5 seconds, right? So if this number is above 0.8, then I spawn. Otherwise, I don't, right? So about one in 5 times, this will be true. Then maybe about 1 in 5 seconds, I'm going to spawn a new rock, right? So I'm going to say if random.random is greater than 0.8, I am going to spawn a rock. So I'm going to say asteroids dot append, and then what I need to append there is a tuple, a quintuple, right? So we're going to have a position, and I'm going to say so it's going to be width times random.random. So this is the x, yeah, and I need a comma at the end. Then the y is going to be height. So random y, right? Dot random. So it's clear that if this is an entity between 0 and 1, then this is going to be an entity between 0 and 800. And similarly, this is going to be an entity between 0 and 600. So it's somewhere in the window. Then we want to have a velocity. So we're going to have, again, velocity limit asteroids. So we're going to have asteroid velocity limit. Let's just copy it because it's a long name and I don't want to misspell it. Times random.random. And then what else do we have? So we're going to have an angle between 0 and 2 times pi, right? So there's a velocity limit, there's an angle. So 2 times math.pi times random.random. And then we have a rotational speed, right? So we're going to have rotational speed asteroid. Let's go again and copy it. Times random.random. Yeah, so about once in 5 seconds, but not exactly every 5 seconds, we will create an asteroid, right? And then inside here, we will render the asteroids, and we're going to have the same approach, right? So we don't want to keep rendering asteroids that have left the screen. They will move in linear direction, and at some point they will leave the screen. And once they leave the screen, we don't want to worry about them. So what was going to be new asteroids is the empty collection for asteroid in asteroids. All right, we're going to have AX, AY. What else do we have there? We have AV for velocity, AA for the angle, and AR for the rotational speed equals A. All right. So then, the next thing we need to draw the image. So we have canvas.draw image, and we're going to have asteroid. Is it asteroid image or rock image? Asteroid image. All right, then from my old code, we have 45, 45, 1990. So the center in the image is at 45, 45, and the size of the image is 1990, right? Then we have the point where we're going to place it, AX, AY. And then we don't want to resize, so we're going to have 1990, but we do want to rotate. And we will, so actually we have 6 elements here. We want the speed, but we also want the angle of rotation, which is we're going to always start at 0. We could start with a random number, but let's start with an angle of rotation of 0. Let's not complicate things too much, right? So we're going to have here an asteroid rotational speed and asteroid rotational angle. Yeah, so here we're going to have the asteroid rotational angle. All right, so we're drawing this. All right, now we have to compute the new elements, right? So new AX is going to be AX plus AV times math.cos AA. Yeah, and AY equals AY plus AV times math.cos.sin AA. All right, this will stay constant for the duration of the asteroid. As long as the asteroid is alive, this velocity and this angle will stay constant, right? The coordinates will change, all right? The rotational speed will stay constant, but the rotational angle will change as well. So we have a new rotational angle, asteroid rotational angle, which will be asteroid rotational angle plus ARS. All right, and if this whole set is still leading to an asteroid being still on the screen, so we're going to have if 0 less than equal new AX less than equal width, and 0 less than equal new AY less than equal height, right? Then we're going to have new asteroids append, and we're going to have this 6 tuple, right? So we're going to have NAX, NAY, AV stays constant, AA stays constant, ARS stays constant. We have NARA here. So we have placed the new place of the asteroid on the screen, and then we have to remember that the asteroids have to be updated. So asteroids is equal to a new asteroid. Good. So what do we have here? We have asteroids, and is there anything else? I think not. I think that's all. No, actually we have these 2 elements here. These 2. All right. So now we should have asteroids. Okay, so as you can see, it's working pretty well. So we have to figure out how to shoot them. So they disappear from the screen slowly. So it's a bit boring. They don't appear fast enough. So we probably need to make them appear a little bit faster. But it's workable, right? The next thing we need to do is let's see how we can shoot them. So let's compute the collision between a missile and an asteroid and make the asteroid disappear upon collision. And then see whether we have the time for today to add explosions. Okay? So how do we compute collisions? Well, whenever the distance between the 2 centers is less than the sum of the radii, we have a collision. Yeah? It's relatively easy. So we have 2 lists, a list of missiles and a list of asteroids. So compute collisions. Oops. We're going to do the same thing, right? We want to make both the missile and the asteroid disappear. But actually, so I think one thing we can just do is delete the asteroid. Can we do that? Let's try again. I can get rid of this. I have an L equals 1. And let's say I have L dot delete 3, and then I'm going to say print L. What does this do? So list does not have the attribute delete. Is it remove? Yes. All right, so we can remove an asteroid from the list. So We're going to, first of all, figure out which are the collided asteroids and the collided missiles, right? So we're going to start with AMT. And we're going to fill these two collections with all the collided missiles and asteroids. Why? Because we want to make them disappear. And once we have found them, we will remove them from the asteroids and from the missiles. So we're going to go for M in missiles, for A in asteroids, right? We're going to have a nested for list. So we have every pair of missile and asteroid, right? And each of them has a center, which is the position. All right. So the first two components in the missile are the position. The first two components in the asteroid are also the position. We can consider that the missile is very, very small, right? So as soon as we touch the distance equal to the radius, we can consider that to be 0. As soon as we touch, we get to the distance of the radius of the asteroid, we can say that we have a collision. So I'm going to say here asteroid radius, and that was 40. It's amazing. You have to be very careful because it senses the proximity and it comes down. All right, so in here, so we're going to say, how do we compute a distance? If I have 2 points, what's the distance between the 2 points? Right, it's delta x squared plus delta y squared and the square root of that, yes? Now, since I have to compute, since square root is always expensive, and since I have to compute just proximity, I can actually say delta x squared plus delta y squared less than radius squared, and then that will get me the same thing. So I'm going to say if, and so let's compute delta x is m0 minus a0, and we don't care which one is greater than the other because we're going to square them, yeah, and when it's squared it's always positive. Dy is m1 minus a1, and then we say if dx times dx plus dy times dy less than asteroid radius times asteroid radius. If this happens, then we can say collided asteroids dot append A and collided is it with a single L or double L? I think it's collision, right? So collided should be with a double L. Append M. All right. And this is it. So we do this exercise for all the pairs of asteroid and missile, right? I take every missile and every asteroid and I check, is this pair collide or not? And then at the end, I'm going to remove the asteroids and I'm going to remove the missiles. So I'm going to say for missile in collided missiles, I'm going to say I have missiles dot remove m. And similarly for A in collided asteroids, yeah, so now we should have collision between missiles and asteroids. So let's see if that happens. I'm not a very good shot, but yes, there we go. Right, we can shoot asteroids. And, oh, it takes so long. All right, I'm going to make them spawn a bit faster. So the spawning speed is, oh, all right. So I think, where is it? Where is it? Here, right? So it's greater than 0.8. Let's make it every 2 seconds, 0.5. Right, so now they're going to spawn a lot faster. Still, they're very slow. Okay, there we go. Okay, I want them even faster than this. They're too slow. Well, let's just have them greater than 0. And now let's make this 100 milliseconds. And let's make this greater than 0.8. Okay, so now they are really fast. And now it starts being a little bit more fun. So we the ship is not destructible yet, but we have a reasonable just remember that you have to click in the window in order to activate the controls, otherwise there's no focus. Okay, good. So this seems to work fine. It works nicely. Both the missile disappears and the asteroid. So let's try to work on explosions. So what happens with the explosion? So this is the image for the explosion. Let's take a look at it. All right, so it's a very long image, right? It's very narrow. The height is very small. Again, the background is transparent, so I can actually not show you how small it is. But we'll see immediately the sizes. And it's 24 images. And in order to have the perception of an explosion, each frame we have to put a different image, one of the different images, right? So we're going to keep moving the center with every frame for 24 times until we exhaust it. Yeah, and at which point the explosion is not there anymore. Cool. So going back here, right? We're going to have a set of explosions, right? So every time we have a collision, instead of just disappearing, we will create an explosion at the site of the asteroid. Yes, because kind of makes sense to have it at the center of the asteroid. So we're going to have a collection of explosions. Now, it could be fun to have the explosion moving as the asteroid was moving. When in one of the past renditions of this class, that happened by accident. But it turns out that it's quite confusing as you play the game. So we're going to keep the explosion at the last position of the asteroid. What do we want to put in the explosion? Well, obviously, we want the position, and we want which of the 24 frames are we at, right? And with each rendering of that image, we're going to increase that frame by 1 until it reaches 24, at which point we delete the explosion from the collection, and then it also is not rendered anymore. The first thing we want to do, since this is the explosion, is we want to place the explosion inside the explosion list, right? So if we discovered a collision, this is where it happens, and we're going to have explosions dot add dot append, and we are going to use the asteroid, right? A0, A1. And we're going to add frame 0, right? This is the 0 frame, the first frame of the explosion. All right? So we remove the missile and the asteroid, and we're going to start the explosions on the next frame. So in order to do that, we're going to put the rendering of the explosions before. Yes, because we're adding the explosions here, so we're already close to the ending of the function. If I'm going to put the rendition of the explosion here, it's going to start on the next frame. So for explosion in explosions, right, and we're going to render new explosions is going to be the list of remaining explosions, right? Explosions are stationary on the screen, right? Just that they might run out of time. After 24 frames, they expire. So each explosion has an EX, EY, and frame. Frame number, let's call it, equals E. And then we will draw the image. So I'm gonna just shamelessly copy this here. I'm gonna use the name of the image, which is here. Oops. I'm generally very forgetful about names, so please bear with me. So this is all right. Now from my own old code, explosions are like this, right? So they have a size of 128 by 128, right? And the center is of course at 64, 64, and it's 24 of them, right? we don't quite care about the radius in this case. We're going to just assume that the explosion doesn't affect anything around. We're just going to use 64, right? And remember, this is the center in the image, right? So 64 plus frame number so it's actually 64 plus frame number times 128. Yeah, and then 128, 128. And then the position on the screen should be EX, EY. And then we're not resizing, so it's going to be 128, 128. And we don't need rotation. So this is enough, right? And then new explosions. So if is less than 24, we're going to have new explosions. And then actually here we have to say 23, because we're going to have 0 to 23, right? New explosions that append, and the position is the same, EX, EY, and then we're going to have frame plus 1. Next time we print the next frame. And this should be it. So let's see if we have explosions now. Explosions should be global. Oh, one important thing that I'm forgetting. Explosions. Yes, and then one thing that I have forgotten is to update explosions. All right. Let's put it up. Okay, so we have explosions. Okay, so now if you're going to tune the speed, I think the asteroids are still a bit too slow to make the game really fun. And also, I think the missile should be faster. So one thing we could do is make the missile velocity 10. Let's see how does this work. Okay, so now it's and I'm a lousy shot. I can barely aim. I think also the rotational speed of the is too fast. Okay, line 162. All right, so it might be the case now that a missile might hit two asteroids, interestingly, and then we might attempt to remove it two times, right? So because of that, let's try to fix this, right? So how do we fix this? I think is so if I say L is 1, 2, 3, 4, and then I say print in L. Does this say true? Yes, so it works like that. So we're going to say if M in missiles, and the same here. So this will avoid the attempt to remove an element twice. Right, so it may be that just by chance an asteroid has collided with two missiles, so there are two removal events, or a missile has collided with two asteroids, right? Because the computation of distance is not precise. Yeah, so if you have two rocks that are tangent, and the missile comes right in the middle in between them, it will be at some point at distance lower than the radius, or they are actually overlapping, right? And it hits both of them. So at that point, it essentially destroys both. And when we do this, because of that, there might be an attempt to remove it twice. All right, so this is fixed, and we have a little bit higher speed. We would need now to check the collision between the ship and the asteroid, and produce an explosion and end the game if that happens. And which means that we would actually be able to finish the game tonight. There are still just 10 more minutes, so I'm not sure we're going to be able to finish that tonight. We're going to spill. I think we need about 15-20 minutes for that. So how about we end here and we do that tomorrow. We also would need to do a bit of cleanup. So let's do the cleanup now, because the cleanup would be easy to do now. All right, so this is the drawing of the missile. So I'm going to take it from here, and I'm going to say draw missiles. Where did I put the other one? Draw ship, draw missiles. Def. And we're going to have some arguments. Let's decide that later. And I'm going to return all right, so what do we need here? We need missiles. We need canvas. We will always make the habit of putting canvas first. Missile image is global. Missile velocity is global. So this should be it. So we go back here and say missiles equals draw. All right. So let's see if everything still runs correctly. Yeah, still everything runs correctly. Okay, everything runs correctly. So notice that once you started the timer, trouble is that every time you want to end the program, you'll have to press reset here. I'm not sure why that happens. The other thing that we want to clean up is this asteroid. So we're going to have a draw asteroids. So we're going to take this and we're going to call it draw asteroids. We're going to need a canvas here at least. All right, then we're going to return as we did before. All right, so we need asteroids. Anything else? No, everything else is global. So we're going to go here and say I didn't delete. I copied. All right, so again, let's try to run. Make sure that everything still runs correctly. Yes, pretty good. So reset again. The next thing we want is to take this one out. So exactly the same, draw explosions. I'm going to take this. Let me try to take it properly from here, Command X. And then we're going to say draw explosions. No matter what, I can't get it right. So we're going to have return new explosions. We also need explosions here. Yeah, and then we go back here and say so this is another one. Let's make sure it works properly. It's all fine. Cool. Then let's do this as check collisions. Actually, I don't think I need a canvas here. We'll see exactly what we need. All right, so I need missiles, asteroids, and there's nothing to return, I think. So let's do what did we say? Missiles, asteroids. All right, again, let's check that everything still works correctly. Set the focus. So I'm checking this to make sure that I can display simultaneously, explosions simultaneously, which is a bit difficult to see. But every once in a while you see at least 2 explosions happening at the same time, which means that the code works correctly. And this is the code that is a lot more cleaned up. All right. So we could also take this into something called new ship position. So calculate new ship position. So let's put this close to the draw ship method. I'm gonna see what we need here. So we will need ship position and friction. And we're going to return, so I don't need to say ship position equals, I'm going to say return. And then right here, I'm going to say ship position equals calculate new and I think I missed a few things here. I wonder why this def is ship velocity x friction. Yeah, so I need ship velocity as well. Ship position, ship velocity. So we're going to say x equals and we're going to make this into a pair is assigned ship velocity, and then we're going to return something more complicated, which is the ship position and the ship x, y, let's align this properly, And then when we calculate the new ship position, we're going to have ship position, ship velocity, which is ship x, ship, let's make more space, and then we're going to have ship position and ship velocity. And then we still need to decompose ship velocity. So ship I made a mistake in keeping two separate variables. But there it is. So let's hope that this now works fine. And it does. Okay, so it is about it. This is the clean code. We're going to continue working on this tomorrow. We are missing very little. What we are missing is just collisions between asteroids and the ship, which are going to be very similar to collisions between missiles and asteroids. And upon that, we're going to have a explosion, and we're going to end the game. Questions? Okay, in that case, class dismissed. See you next time.